Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video we're going to build ourselves a dry box for our FDM 3D printer. So quite a lot of filaments are hydroscopic, that is, they absorb moisture, and depending on the type of filament it is as to what kind of effect you're going to have. Filaments like PA or nylon are extremely hydroscopic. They will absorb moisture from the air while you're printing. So you can start out with a brand new fresh roll and be a quarter of the way through your print, and it is essentially useless because it's absorbed so much moisture just from the air. Filaments like PLA, if you leave them sit out in the open in humid or wet weather for 1 or 2 weeks unused, will just become brittle and break. Other filaments like TPE or TPU become difficult to print because they start popping and carrying on as they print and can lead to excess stringing and binding of parts together. PLA also has cracking and popping sounds when it's fairly high in the moisture load as well. So to prevent some of these problems, one of the solutions is to always store your filament in a sealed container, preferably with a desiccant. Another method is to use a heated box so that it was always repelling the moisture. Or you can store them in a box with desiccant and a spool holder and feed the spool or the filament straight out of your box, also known as a dry box. Some of the dry boxes you can buy on the market are relatively expensive. So in this video we're going to build one. So I've 3D printed these parts. I'll link to the STL file. I actually created this one. After I printed it, and I did use a clear filament, which is never clear when you printed them. I'll finally print them. I did have to countersink these holes because I am using countersunk screws or flathead screws, and I needed these to sit flush on the inside. And the reason for that is what we're going to do is put those through, put a washer on the inside with a threaded rod. Then with our bearing installed, put that onto the shaft and you'll get a little bit of clearance. And that will allow that to spin. Alright, so other items you will need are these are M5 screws. They are 16mm long. So M5 by 16 long. M8 threaded rod. This one's cut to 130mm long, but I have got another one just in case at about 116, 117. A lot of that is dependent on the size of your box, the depth of your box. So if you can measure from the lid to the bottom and then add room or add the thickness of this, which is 4mm. So 4mm plus the thickness of your nut. On the M8 threaded rod, I'm attaching a nylock, an M8 nylock. This has a nylon insert in it and locks them onto the shaft quite well. And then I just use ordinary nuts everywhere else. The nylock is to make sure it doesn't undo. I could have grabbed another nylock and wound it on later to clamp this one in place, because we are going to have a nut in there holding it. And the idea with these, let's start with, this is an outer piece, then we have the inner piece, and that will one piece on the outside of our box, one on the inside. The screws clamped together. Then we put on our washer. Then we put on our cone and we'll lock it in place with a nut. Then once we've got our bearings in this one, you put your roll of filament on. You put your second cone on. You can put a washer on and lock it up. This might be too long looking at it now. You can use a wing nut if you like. These are an M8 wing nut, but I found my box is just that little bit too shallow that the wings tend to foul on the lid, and we want to be able to put the lid on. So let's get stuck into getting this set up for it. So before I forget, you will need for this project 4 608 bearings. These are just cheap Chinese ones. In Australia they're about $2.50, $2.60 thereabouts. This is a compressed air fitting, but we use it for PTFE tube. It takes a 4mm OD tube and it has a thread which threads into this 3D printed part. This is a bulkhead entry for that. Has a hole that allows that filament to go through into this, and then we can run PTFE tube all the way out to our printer, which is what I've done for a very long time with my TP filament. So this is an early prototype that I made. So I have my TP spool in here. This is a different bulkhead fitting. I couldn't find the original one I made or found on Thingiverse anymore. But I've been using this for over 3 years. This roll of filament is over 3 years old and still works well because I've kept it in the box the whole time. And in the back you can see the little packets of desiccant in there, silica gel. I did manage to crack the base on this as I was putting it together, so we're going to endeavour to not do that this time round. So let's get into putting this one together. So the first thing we really need to do is find the middle of our box. The easiest way to do that is to get a ruler and go from diagonal corner to diagonal corner. Then with a marker, roughly in the middle, put a cross. There is actually marks on this from where it was manufactured. I just ran over it with my marker. And there's the middle of our box. And we're going to drill a hole through this. I would suggest possibly drilling from the inside out with it sitting on some wood, or you can rush it like I'm about to do. Just take it easy as you drill it. Now that hole will need to be an M8 or an 8mm hole or an M8 thread. That hole I drilled, by the way, was 5mm. We'll make this 5mm for the next one. That is a bit long. That one might be just that tad short. And what I'm just going to do is put a nut on the end of this so it doesn't fall through. I will transfer the nylock onto it. And then we're going to drill a hole through. Now we can poke one of our screws through. That'll hold it in place while we do the other side. Okay, so with our countersunk version, we can now put that in. Now on the other side, we put our plate on, we get our nut and we put our nut on. Grab the shifter. Now we want these firm, but we don't want to over tighten them. If you over tighten them, you will break the plastic. So these large discs that I've made will reinforce the bottom and make it stronger. Now I'm just going to take that nylock off that. Actually, no, I want to go the other way, don't I? So we want the nylon in the nylock to engage on the thread, and that'll make sure it doesn't come off. And now feed that through our hole. I'll just run the drill through that again just to make sure it's clear and open all the way. Okay, so we're putting our washer on, and then we can put our cone on. Then we'll put another nut on. Now you can use another nylock here. The difference between using a nylock here and just using an ordinary nut is the nylock will be tight all the way down. Whereas here, if we just use another nut, an ordinary nut, we can tighten it up and this will spin quite freely on the unit. All right, before we can put this one on, we do need to put the bearings in. So these will be tight. They're a 22mm outside diameter, 8mm inside diameter, 7mm thick bearing, and that print is designed to come out at 22mm diameter on the inside here and on here. And I don't think I had the printer quite dialed in properly, so I'm just going to install these with a little bit of gentle persuasion by a hammer. Okay, so to show how a roll works in that, this is an old roll I've had sitting around for a long time. And I probably should have used the slightly longer one. But nonetheless, that works. So I'd go around 120, 125 mil long. The 130 I think is just that little bit too long. Okay, so we know that part works. I'll probably shorten this one down by 5 mil and use it in the end. So the idea is, once we put our lid on, it is going to be airtight. That poses a problem for getting our filament out of it. So what we need to do is put a bulkhead on, and that's this part. So these are a M3 screw. You may have to drill your holes out to 3mm just to make it easier. Alright, so when we put this on, we want to put it down near the bottom. Some people like to put them in the middle, but the truth is it's coming off the outer edge of your roll, so you want to put it down near where the outer edge of your roll is. We're going to have 3 holes going through there. Our filament is actually the better template to use. Our filament's 1.7mm in diameter. I think that hole in the middle there is actually closer to 3mm. probably 2.5. They're 3mm holes. We might take that out to 3mm anyway, but we'll do that after we get it mounted. So we work out where we want to put it and drill our first hole. Just countersink this hole just to clean off some of the rubbish around it. And what I'm going to do is just poke the screw through and through that hole. Work out exactly where I want the next one and use that hole as a guide. And now we're last hole. All right. So this piece we use for our template is actually for the inside. Now, if you're really keen, you could put some Celastic or something of the like just around like a gasket, or a fine bit of something like a table mat, non-slip mat that can be compressed up to help make it an airtight seal. Because I am using nuts and bolts, I don't think it'll be necessary this time round. Now on this part when you print it, it's got a flat side and a side that has got a countersink in it. You want the countersink on the inside and the flat side against the wall. That's because the countersink makes it easier to feed your filament in later. And on the inside we put our nuts. Now I'm using these square nuts because I can, and I've got a heap of them. You can use a hex nut if you like. There's no reason you can use a nylock. In this case, they were the best fit for the screws that I grabbed out. A lot of this is made using parts I just had lying around from building robots. Right, and that is pretty much our completed dry box. Give it a bit of a clean out, find a couple of bags of desiccant gel. They come in lots of pre-packaged products where they want to keep them dry. Electronics, I think the two that I'm using in the other one actually came with one of my power supplies. Nearly every roll of filament you get will come with a small pack of desiccant to help keep it dry. This is not quite a square box, it's sort of rectangular. And that's our box. Now, I suggest sitting it up on its end like this when you're using it. I found that when they're sitting flat like this while using, the roll can continue to wind on it a little bit and then it falls over the side and it becomes a tangle for you. You have to open it up and untangle it. So if you leave it sitting up on its side, it doesn't tangle like that. So that'll do for this video. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. The ringing of the notification bell will let you know when future videos come out like this. If you'd like to help the channel further, I do have a Patreon account. You can join my long-term Patreons, VIPs Go Lucky and Lawrence Berger, as well as my builder level Patreon, Elmorales45. All my Patreons get these videos a couple of weeks early. If you've got any questions, feel free to leave questions in the comments, or you can join me in Discord. There will be a link in the description to the Discord channel. And we'll see you in the next video.